You don't need to know how foundation models work to use them, but it's helpful to learn a bit about the vocabulary, especially around large language models or LLMs. LLMs use the context of words in a sequence to make an educated guess about what should come next. So if someone said, "The cat jumped onto the," you might predict that the next word is couch or table. By using the context of words in the sentence and your knowledge of how cats behave, you've made a pretty good prediction. Of course, the next word could be kayak, but that's much less probable than couch. Large language models use a similar approach, but on a much larger scale. They look at words, word sequences, and context, and use the patterns and relationships they've learned to predict what should come next. 4 important concepts that support this process are tokens, embeddings, vectors, and transformers. An LLM converts text into tokens. Each token might be a word part, or a character. For example, the sentence, 10 cats jumped onto the table, might be broken into 8 tokens, 1 for each word and 1 for the exclamation point. The model uses the tokens to employ a technique called embedding, which stores and represents related information as high-dimensional vectors. A vector acts like a set of coordinates that pinpoints a location in this multidimensional space. Semantically similar items are positioned closer together, and dissimilar items are farther apart. Vectors allow the model to understand that concepts like cat and kitten are related, but cat and king are less so. LLMs learn to represent entire sequences of text as vectors, not just words. This enables the model to generalize and make inferences based on complex patterns and relationships. Transformers are a type of neural network architecture that's very efficient at processing these vectors and understanding the relationships between them. Rather than processing strings of text sequentially as earlier neural networks do, transformers can look at different parts of the sequence all at once and determine the most important parts. Transformer architectures have been a big contributor to the rapid growth and availability of large language models. Of course, the specific details of how each LLM learns and responds is very complex and can vary across different LLMs and architectures. But the concepts of tokens, embeddings, vectors, and transformers are core components of modern large language models.